All right, welcome back. This video is for Learning Target 5AB, pages 19 through 22. And we can go ahead and get started. Turn to page 19. Our learning target for this lesson is we're going to be able to convert between scientific notation and standard form. And that is numbers greater than 1 and numbers less than 1. So scientific notation is our lesson. So let's figure out what scientific notation actually is. So some vocab here. Scientific notation is a way to write really, really, really big numbers or really, really, really small numbers in a readable manner. Okay, so you're going to see this, a lot of time you see this in science too. So really, really large numbers or really, really, really small numbers are usually written in scientific notation. Book definition of scientific notation says this: a number written with a coefficient of at least 1 but less than 10, and it's multiplied by a power of 10. Okay? So in 8th grade terms, what does this mean? Basically what this means is this. This is what standard form looks like. You've got this number, and they call it a coefficient. Okay, the number that falls in this first part of this form here has to be at least 1 but less than 10. So in other words, I like to think the number that's in this box has to be between 1 through 10. It can equal 1, but it can't equal 10. It has to be multiplied by a power of 10, so you'll always see times 10, and then you're always going to see an exponent, okay? Now, a few rules about the exponent. If the exponent from this power of 10 here happens to be a positive exponent, you know we're talking about a number that's really large. It's larger than 1, okay? If the exponent is a negative exponent, then you know we're talking about a number that is less than 1, but more than 0. So in other words, it's between 0 and 1. So keep those two things in mind today, okay? Positive exponent means it's a number you're talking about more than 1. If it's negative, you know the entire number is between 0 and 1. It's that very, very small number. So let's talk about what scientific notation looks like, okay? Let's talk about numbers that are greater than 1. So in other words, here's a scientific notation number, 3.8 times 10 to the 4th. What does this mean? Basically what this means is 3 times 8 times 10 to the 4th means you're multiplying 3.8 by 10 4 times. Okay, so if we're going to do this the long way, because before I show you the shortcut, I want you to know why the shortcut works. I'm going to multiply 3.8 here by 10 4 times. So here's the first time, 3.8 times the first 10. Well, I don't need a calculator for this because anytime I multiply by 10, I know I'm going to move the decimal point one place over because there's 1 0 and 10. So 3.8 times 10 is 38. Let's take 38 then times a second 10. 38 times 10, well, I have 1 extra 0 here, so I know I'm going to move the decimal point, which is at the end of 38 here, and I'm going to add another 0, so this is 380. I'm going to take 380 times a third 10. I know that there's a decimal point. I'm going to add another decimal place, so this is 3,800. And then I'm going to multiply 3,800 by a fourth 10 because it says to the 4th power. And I know that I'm going to take this and add one more 0 to it to add another decimal place to it, and I'm going to end up with 38,000. So in the end, 3.8 times 10 to the 4th actually does equal 38,000. Okay, if you punch this into a calculator, you're going to notice it's going to say 38,000. So that means if the exponent is a positive exponent, notice it's a positive 4, you're going to always move the decimal we moved it to the right because we made our number bigger. So we're going to move it to the right. Okay? What happens then if we have a number that's less than 1? You're going to notice it's a negative exponent. So let's take a look here. What does 4.2 times 10 negative third actually mean? It actually means that you're dividing 4.2 by 10 3 times. So this negative 3 here means that you're dividing. You're not multiplying anymore. You're dividing by 3 different times. So let's take this 4.2 and we're going to divide by 10 3 different times here. So if I take 4.2 divided by 10, I know I'm not going to get a number that's larger. And the reason why is because I'm dividing by 10, there's one zero. If you need a calculator for this, you can do 4.2 divided by 10. Otherwise, the rule is you're going to move the decimal to the left. So 4.2 divided by 10 actually equals 0.42. You move the decimal place one place smaller. 0.42 now, my new number, divided by a second 10. Well, I'm going to move this decimal one place over. So I'm going to get a 0 in that extra place there, 0.042. And then I'm going to take that new number, 0.042, divided by a third 10, because I have a negative 3 here. I'm going to move that one place over to the left, and I'm going to get in that extra place a 0, and I already have a 0.42 here. So in other words, in a calculator, if you give this a try, it's going to say this answer here in your calculator, 4.2 times 10 to the negative third power equals 0.0042. In other words, if the exponent is a negative exponent, it's going to be a number between 0 and 1. You know you're going to move the decimal point this time to the left. You're going to move it backwards. Okay? So let's give some of these numbers a try. You're going to write each number in standard form. You're going to do this without a calculator, just following the rules we just talked about. So let's take a look at the first one. Let's try the first one together. We have 8.1 times 10 to the 9th power. Because we have a positive exponent, I know this is going to be a really large number because we're taking 8.1 times 10 9 times here. Now here's the shortcut, so we don't have to write this work all up like I just showed you here. I'm going to take my number 8.1, and I'm going to take my decimal point. Notice it says move the move the decimal to the right. And you're going to move that decimal as many times as the exponent says here. So here's my decimal point. I'm going to move it 9 times to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And what am I going to do with all those empty spaces? I'm going to fill them up with zeros. And here's another secret. If you don't want to count these, you can just know that it's always 9 numbers right after the decimal point. So you're going to notice 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. I already had a number, so I added 8 zeros to it. And then the last part, you just have to know where to put your commas to actually be able to read the number. So I'm going to start at the end. I know it's commas every 3 numbers here, so there's a comma here, here, and here. So our actual answer is really large number here. This is thousands, million, billion. So this number reads 8,100,000,000. Okay? Let's give the bottom one a try. 4.01 times 10 to the 4th, positive exponent. So I know I'm going to move my decimal to the right 4 times. It's going to be a large number. I'm going to start with my original number, 4.01. I know I'm going to move my decimal place 4 places to the right, or I know I'm going to have 4 numbers after the decimal point. So I already have 2 numbers here, and so I know I'm going to have 2 more zeros to have 4 numbers, and you can check out this. 1, 2, 3, 4. Notice I moved the decimal point 4 places to the right. So then I'm going to figure out where to put my comma here. Come from the back. 1, 2, 3. I know my comma goes right there, so final answer, 4,100. So 4.01 times 10 to the 4th is another way to say 4,100. Good. Let's take a look at some negative exponents. Remember, negative exponent means we're talking about a number, but that's between 0 and 1. So 3 times 10 to the negative 5th power. If I have a negative exponent here, I'm going to move my decimal to the left 5 times. Okay, so it's a pretty small number here. So let's start with 3. Where's my decimal point? My decimal point is right after the number. That still represents 3. Okay, and I'm going to move this over so I have some room here. Let's move our decimal point 5 places to the left, because we don't want a number that's too big. We want a number that's small. So 1, 2, 3, 4, 5. And that's where our new decimal point is. And all these empty spots we're going to fill in with a 0. So final answer, 0.00003. And there you go. And then the secret to this one is count how many numbers still are after the decimal point. There should be 5. So here's a decimal point, 1, 2, 3, 4, 5. Okay, so that's in case you lose count of your decimal places. So there's your final answer for that one. Let's give the last one a try. 7.02. Notice I have a negative exponent. That means I'm going to move my decimal point 3 places backwards. So here's our decimal point. 1, 2, 3. There's our new decimal point. Let's fill in the empty spots with zeros. Final answer then is 0.00702. And if you want to put a 0 here, you can. 0.00702. And again, let's check. Is there 3 numbers after the decimal point? 1, 2, 3, and yes, there is, because that's originally where the old decimal point used to be. Okay? So if you were confused at this point, make sure you're pausing it and asking questions before we move on here. Okay, you should be on page 20 here. Oh, no, we don't want to update. So now we're going to be able to work the other way. I'm going to give you a number that's in standard form. So in other words, it's just a normally written number, and we're going to write it back into scientific notation. So the previous page we were given a number that's in scientific notation, and we changed it to a standard form number. Now we're going to go the other way. So recall that scientific notation, this first number has to be between 1 through 10, times 10, and then we have an exponent. So we know that if it's positive exponent, it's a number bigger than 1. If it's a negative exponent, it's between 0 and 1. So let's take a look at 5,920,000. I know I'm going to have a positive exponent because this number is bigger than 1. So what we're going to do here is, in this first box, remember this first box has to be a number that's at least 1, but no bigger than 10. So between 1 and 10. So you have to decide, looking at your numbers, these zeros after here are insignificant. So between the numbers 5, 9, and 2, my decimal point, where am I going to put it that makes it a number between 1 through 10? Well, I'm going to put it between after the first digit here, obviously, because I want my number to be 1 digit. So I'm going to create a number with the actual numbers that aren't zeros, and I'm going to create the number 5.92. Okay, that is between 1 through 10. And then I have to decide, I already have the times 10 part, what number is going to go in the exponent. Well, this is where I'm going to count how many numbers are after my decimal point that I placed there. And I can see there are 1, 2, 3, 4, 5, 6 numbers. So my exponent here is going to be 10 to the 6th. So I took 5.92 and I multiplied 10 6 different times, which moved the decimal point 6 places all the way to the end of the number. Okay? And you can give that a try. If you punch in 5.92 times 10 to the 6th power in your calculator, you will get 5,920,000. All right? Same thing with the small number. Notice this is 0.00087. We know this is going to be a negative exponent because we have a number smaller than 1. Okay, so we know it's going to be negative here. And now I still follow the same rules. I have to figure out a number that's between 1 and 10 that goes in this first box, and it's always times 10, and we know it's going to be a negative exponent. So I have 8 and 7 are my numbers in here that aren't zeros here. These zeros really don't matter. They don't do anything for you to figure out the first number in the box here. And I'm going to put my decimal point between the 8 and 7, which creates the number 8.7. That is a number that falls between 1 through 10. And let's decide how far away is that decimal point that I placed there from the original decimal point, which is right here. So let's take a look. There are 1, 2, 3, 4 numbers in between the old and the new decimal point. So I know my exponent is going to be a -4. And again, it's negative because I have a number smaller than 1. It's between 0 and 1. Okay, so that means if I took a 0.7 and I divided it by 10 4 times, I'm going to get 0.00087 because it's 1, 2, 3, 4 places from the new decimal point that I'd put in place. Okay, so let's give a few a try here. It says write each number in scientific notation. First one here. And notice I'm going to always draw this to give you a hint on this is the form. You just have to figure out these 2 boxes. The first box, where am I going to put the decimal point? I'm going to put it between the 6 and 8, so I have the number 6.84. That fulfills the not the recommendation, but the need to make that number between 1 through 10. Then I have to decide, because it's a large number, I'm going to have a positive exponent, how many numbers or how many places am I going to move my decimal point to get all the way to the end of the number? Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So the final answer is 6.84 times 10 to the 10th power. Let's try a small number. We have a number smaller than 1, bigger than 0, so I know I'm going to have a negative exponent. I'm going to put my decimal point between the two 7s, so I have a number 7.7, which is between 1 through 10. And how many numbers stand between the new decimal point and the old one? There are 1, 2, 3, 4. So I know that's going to be a 4 here, and I know it's going to be negative because it's a small number here. Okay, that means I took 7.7 and I divided it by 10 4 times to get the number 0.00077. Okay, so give this video a pause and then check back on the 2 problems below. Give it a try yourself, and then you can check your answers. Okay, let's take a look at how you did here. This first one, number larger than 1, hopefully you put your decimal point after the 4. So you're going to have 4.02, and I know I told you that zeros don't matter, but this 0 between the 4 and 2 does matter because there's another non-zero number that's after this first 0. So we're going to get 4.02. There are 3 numbers following that new decimal point, so you know your exponent is a 3 here. Numbers smaller than 1 but bigger than 0, you know you're going to have a negative exponent. We're going to place our decimal point after the 5 here, so we're going to get 5.02. So this 0 right here is important because it falls between 2 non-zero numbers. And then how many numbers fall between the new and old decimal point? There are 1, 2, 3, 4, 5, 6 numbers, so our exponent is a negative 6 because we have a number that's between 0 and 1. So again, make sure you're pausing and asking if you are confused about anything. Last part, what does scientific notation look like on a calculator? What does it look like in calculator language? All right, let's take a look at a first example here. It says 7.3, and then we have a capitalized E, and then a 5. So basically what this means is this. This E is calculator language for scientific notation. Okay, so what it means is 7.3, E5 means 7.3 times 10 to the 5th power. In other words, the 7.3 is your number that's that first box between 1 through 10. The second number after the E is going to be your exponent. That E in calculator language is basically the 10 to what power. Okay, so what does that look like in standard form? So by now we should know we're going to take this decimal point, we're going to move it 5 places to the right. It's a positive exponent, so it's going to be a large number here. So we're going to take 7.3 and go 1, 2, 3, 4, 5. Fill in our empty spots with zeros, and our final answer we know is 730,000, because that's where my comma is going to go, 730,000. So I wanted to show you how you punch this in a calculator. So let's take a look. You should have a calculator with you. So where does this E look like on or where is it found on a calculator? Well, in order to punch in 7.3 E5, you're going to use 7 and then decimal point 3. And then to get the E, you're going to notice it's on the calculator, it's a double E. Not sure why it's a double E or a single E. Same thing. You have to use the second key and then the EE key. If you're using my calculators, right above the 7, you'll see the EE. So you have to push that, and you'll notice one E appears on your calculator. And then push a 5 and push equals. You should notice you're going to get an answer of 730,000. Okay, so that's just a shortcut way of putting that into your calculator so you don't have to type in 7.3 times 10 to the 5th power. That E shortcuts the times 10 to the whatever power for you. So in other words, Let's take a look at the bottom one. If I want to represent this really, really, really large number, okay, this is thousands, millions, billions, trillions, quadrillion, I think that's after 2 quadrillion, 500, big number, okay? Let's go ahead and rewrite this in scientific notation. We know that our first number is 2.5. It's numbered between 1 through 10 times 10. How many numbers are after our decimal point that we had placed here? Well, there are 3, 6, 9, 12, 13, 14, 15. So I know this is to the 15th power. So how do you write this in calculator language? Well, it's pretty much what you see in scientific notation. It's going to be 2.5. And remember that E represents the times 10 part, and our exponent is 15. Now, if you try typing that into your calculator, take a look, type it in, you're going to notice that it doesn't actually give you this big number because the number is too big to even fit in the calculator. It's going to bounce it right back to you in scientific notation. This is why you cannot rely on a calculator to read scientific notation numbers. You have to be able to convert it yourself. Okay? Same goes with really small numbers with negative exponents. Basically, 3.3e to the negative 7th means 3.3 times 10, and then to the negative 7th power. So what does this look like in standard form? Well, we're going to move that decimal point 7 places this time backwards to the left because we want a really small number. So let's do our work here so we can see it. 1, 2, 3, 4, 5, 6, 7. So there's my new decimal point. Let's fill in all our empty spots with a 0 here. And we should have our final answer as 1, 2, 3, 4, 5, 6 zeros, 1, 2, 3, 4, 5, 6 zeros, and then a 3, 3. Really small number. Why don't you give it a pause and give this very last problem a try, and then come back and check your answer. Okay, let's take a look. You should have 3.12 e negative 10. That's what calculator language would look like for the scientific notation number. And final answer should be, you should have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, and then a 3, 1, 2. Why? Because there was your old decimal point between the 3 and 1, and there should be 10 numbers in between the new and the old decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, there is. Okay, so there's your final answer without that decimal point there. All right, let's give you a summary here. Final summary piece is, know that scientific notation is some number that has to fall between 1 and 10. It's times 10, always, always, always. And then you have an exponent. A positive exponent means that your number is larger than 1. Larger than 1. And a negative exponent means that it's numbered between 0 and 1. Really, really small number. And last thing I want to emphasize here, because I think a lot of people misunderstand, the exponent does not mean how many zeros you place in your new number. Okay, it's how many numbers are in between the old and the new decimal point. It's not how many zeros, it's how many actual numbers. Okay, make sure you're asking questions, and then give a few problems some practice to see if you actually can do some on your own. Good luck!